Self Santhosh Kumar Kulakarni, Assistant Professor of Department. I have 3 years of experience in Peter College. I am dealing micro and optical communication. Today's topic is also called as hybrid T. It is a 4-port device. So let us now understand what is the use of a magic T in micro. Magic tree is also called as power divider. When an input is given to any port, power is equally divided to remaining ports. It is a hybrid microwave component. It is constructed using E-plane tree and plane tree. It is a combination of E-plane tree is a 3-port device. Here E stands for electric field. Your electric field is parallel to your electric H plane tree is nothing but your magnetic field. Here H arm is parallel to your magnetic field. So magic tree is a combination of these two things, that is E plane T and H plane tree. So why it is called as a magic, we will learn in this today, and also we will study the S matrix parameters of magic tree. So what is the use of S matrix of magic tree? S matrix stands for scattering matrix. If you study the S matrix parameters, we can know how much reflected power is there through that waveguide junction. Not only reflected power, we can also know what is the transmitted power from that waveguide multiport junction. So let us understand the structure of magic tree. This is a structure of the magic tree. It consists of 4 ports. So the names of the ports are port 1, port 2, port 3, port 4. Port 1 and port 2 are collinear. Collinear arms are also called as side arms. Port 3 is nothing but your H arm, where H stands for magnetic field, and port 4 is E arm. It stands for electric field. Let us see the polarization of your electromagnetic signal. What is electromagnetic signal? Electromagnetic signal is nothing but your microwave signal. So let us see the polarization of the EM signal. Here electric field is parallel to your E arm, and magnetic field is parallel to your H arm. So let us understand the operation of the magic tree. When an input is, let us understand with 3 cases. First case, let us see the first case. When input is given from E arm, First case is when signal is given at E arm. What is E arm here? Port 4 is a E arm your microwave waveguide component. So when input is given at E arm, the power is equally divided. The power is equally divided to collinear arms. So let us consider 100 watts of power you are giving to port 4. Then 50 watts of power is coming out of port 1 and 50 watts of power is coming out of port 2. The power is equally divided to collinear arms, and these signals are 180 degrees out of phase. So what is the operation here? When an input is given, at E arm, what is the operation? The power is equally divided to collinear arms, but signals are 180 degrees out of phase. This is the first case. Let us see the second case. Second case is when input is given at H arm. What is H here? H is nothing but your magnetic field. When an input is given, which one is H arm here? Port 3 is H arm. When an input is given at H arm, how we are giving input to magic tree? We have to connect some waveguide oscillators. Like popular waveguide oscillators are klystron power supply. We have two cavity klystron, we have reflex klystron, we have magnetron. So when we are connecting a microwave oscillator, this generates microwave signal. So that signal, when you are connecting to port 3, the case 2, you have to understand this, very important. Case 2 is when you are giving input at port 3, the power is equally divided. Here also the power is equally divided to collinear arms, but these signals are in phase. See the difference between case 1 and case 2 is when input is given at port 3, the signal is equally divided to port 1 and port 2, and those are in phase. So write down, all of you. So power is equally divided to collinear arms. Here collinear arms are nothing but port 1 and port 2, and are in phase. These two cases are very, very important in order to understand the operation of magic tree. At the end of my class, you will understand what is a magic in your magic tree. So let us go for the case 3. Case 3. In case 3, I am using two microwave sources. What is a microwave source? I am repeating that microwave source is nothing but what? It is a microwave oscillator. It may be a two cavity klystron, may be a magnetron, or it may be a reflex klystron. Without using a microwave source, can we generate a microwave signal? No, it is not possible. Why? Because in order to generate a microwave signal, we have to use a microwave source. We can use any microwave source here. Okay. So in case 3, I am using two microwave sources. One is connected to port 1, another is connected to port 2. if these two microwave signals are given input to collinear arms, what will be the operation of your magic tree? See here, when case 3 is I am giving inputs at port 1 and port 2. So what will happen here? The two signals are added. That added signals will be coming at port 3 and subtracted signal will be coming at port 4. Okay, so at port 3 we get signals added, and port 4 we get subtracted. Based upon these three operations, we will derive the scattering matrix of magic tree. See here, this is very, very important. These three cases are very, very important in the derivation of the scattering matrix of magic tree. First case we have studied. What is the first case? When input is at E arm, we are getting the outputs at port 1 and port 2, and the signals are out of phase. And case 2 is when input is at H arm, we are getting outputs at port 1 and port 2, and signals are in phase. Third case is when two inputs are given at port 1 and port 2, we are getting added signal at port 3, subtracted signal at. Based upon these operations, we can name E arm as a subtractor arm or a difference arm, and H arm we can name it as added arm or sum arm. Why? Because the summed signal we are getting at E arm, and subtracted signal we are getting at H. Now we will derive the scattering matrix of magic tree. Okay, so what is scattering matrix? You have to know. Okay, so all of you draw this diagram. Remember this operation. Why? Because this operation is very, very important in the derivation of the scattering matrix. Every microwave engineer has to know what is the scattering matrix of my microwave component. Then only he can understand how much power is reflected and how much power is transmitted through that microwave component. And now I want to tell some applications of magic tree. Why? Because when we are learning about any topic, okay, we have to know the advantages of that magic tree, and also we have to know what are the applications of magic tree. This magic tree can be used to measure the impedance of an unknown device. That is the magic. See here, we can do lot of applications with a magic tree. We can use this magic tree as a mixer. What is a mixer? We are using in a super heterodyne receivers. Mixer is nothing but what? We are converting an RF signal to intermediate frequency signal. At that time, we are adding some frequency to your received signal. So this can be used in radar systems. Not only in radar systems, in satellite communications, we can use a magic tree. And not only we can use as an isolator, we can use a magic tree to measure the impedance of an unknown device. So magic tree can also be used to measure the impedance, and also it can be used to measure the values of your unknown device. Let us derive the scattering matrix of a magic tree. Scattering matrix is also called as S matrix. In short, we call it as S matrix. For any microwave component, S matrix is a square matrix of order n by n. It is a square matrix of order n by n, where small n stands here the number of ports in the waveguide junction. So in magic tree, our topic is magic tree. How many ports are there in magic tree? We have studied in the previous slide the structure of the magic tree. So how many ports are there in magic tree? There are 2 collinear arms and 1 E arm and one other one is H. Total 4 ports are there. So what is a scattering matrix? What is the S matrix of your magic tree? Yes, it is 4 by 4. Why? Because it has 4 ports. It has 4 ports. So square matrix or S matrix of magic tree is 4 by 4. Now let us define the scattering parameters of this magic tree. Your scattering matrix is denoted by a capital letter S here. The parameters of the scattering matrix depends upon the number of ports in that multi-waveguide junction. So the first parameter is S11, second one is S12, S13, S14. What is the order of this matrix? Is 4 by 4 matrix. Now S21, S22, S23, S24, S31, S32, S33, S34, S41, S42, S43, S44. So how many parameters are there in the magic tree? Totally 16 parameters are there. Now we have to simplify the 16 parameters. In my today's class, I will derive the final S matrix of magic tree. So now apply the scattering parameters properties to this S matrix. The first property, in your magic tree, port 3 and port 4 are perfectly matched. What is port 3? Port 3 is nothing but your H arm. What is port 4? Port 4 is nothing but E arm. If these are two perfectly matched, what is the meaning of perfectly matched here? Perfectly matched means there will be no reflections. There will be no reflections when we are connecting a microwave source to these ports. If these are perfectly matched, then S33 is equals to S44 is equals to 0. What is S33? S33 is nothing but when we are connecting a microwave source to port 3, there will be no reflections. What is S44? S44 is nothing but port 4. What is port 4 in your magic tree? Port 4 is nothing but your H arm. So substitute these values here now. I am erasing this one. Directly I am writing out, simplifying the S matrix parameters. So substitute in S33 place, I am substituting it as 0. S44, I am substituting it as 0. Next, apply E-plane property. What is E-plane property? E-plane property is nothing but S S14 is equals to minus S24. Clearly we have to understand here, fourth port is nothing but what? See the diagram, all of you see the diagram. In the diagram, fourth port is nothing but your E arm, that is nothing but transmitting the electric field. It is parallel to your electric field. So why minus here? Anyone, why minus here? S14 is equals to minus S24. When we are giving input at port 4, the power is equally divided to collinear arms and the signal is 180 degrees out of phase. That's why here minus. So I will substitute afterwards, all things I will substitute at the end of my applying the properties. Okay. Next, apply H-plane property. What is H-plane property? S13 is equals to S23. What is the meaning of this S13 is equals to S23? When we are connecting a microwave source to your HM, the power is equally divided to collinear arms and the signals are in phase. That's why here there is no minus. S13 is equals to S23. Now next, applying the another property, that is nothing but your isolation property. Isolation property for port 3 and 4. Here port 3 and port 4 are isolated ports. Why they are isolated ports? In case 1 there is no output at port 4. In case 2 there is no output at port 3. When input is given at E arm, the power is equally divided to your collinear arms, but there is no output at port 4. When we are giving an input at H arm, the power is equally divided to collinear arms, but there is no output at E arm. So that's why port 3 and port 4 in your magic tree or hybrid tree are isolated ports. So applying this property and substituting these parameters, S34 is equals to S43 is equals to 0. Substituting all these properties. Next one, last important property is nothing but your symmetry property. I will write here, left side. Symmetry property. Sij is equals to Sji. What is the meaning of Sij is equals to Sji? When we are giving an input from I port or from J port, the operation of the signals in your waveguide is same. That is nothing but the symmetry property. So applying this one. So applying the symmetry property, we can define the scattering parameters. S21 can be written as S12. S31 can be written as S13. S32 can be written as S23. And S41 can be written as S14. S42 can be written as S24. And S43 can be written as S34. Now I am applying all these properties in your scattering matrix. So I have applied this S33 as 0, S44 as 0. Now S21 can be written as, from symmetry property, S21 can be written as S12. Okay, so see the simplification. Now S23 from the H plane property, how we can write down S23 from this property? S23 can be written as S1. Okay, now next S24. How we can write down S24? From E plane property, S24 can be minus, you can take this side, LHS side. So S24 can be written as minus S14. Now simplifying this parameter S31 can be written as S13 from the symmetry property. See the left side. Next S32. How we can write down S32? S32. S32 can be written as S23 from the symmetry property and from the H-plane property. S23 is nothing but S13. Any doubt in this? Okay. Next, this parameter is 0. Next one is S34. So how we can write down S34? S34 from the isolation properties directly it is 0. Okay. Now next is S41. S41 from symmetry property S41 can be written as S14. Next parameter is S42. S42 can be written as S24 from the E-plane property S24. If you send this minus this LHS side, S24 can be written as minus S14. Next one is S43. What about S43? Now you have to tell this answer. What is S43 here? From symmetry property, S43 can be written as S34, and S34 from the isolation property it is 0. See, in our derivation previously we have 16 parameters. Now we have simplified the 16 parameters to how many parameters? 5 parameters. Like this, the simplification of S matrix can be done, and clearly here we can see that the minus sign indicates that when we are giving the input from E arm, the signals are out of phase. When we are giving input from H arm, the signals are in phase. So in the next video we will continue the applications of magic tree. Thank you one and all. Thank you for watching the video.